All right, guys, this is April 23rd and GCF. So when it comes to GCF, that means greatest common factor. So what we're looking for here is the greatest common factor between two terms, and we're just going to start out with numbers. Okay, now, one of the other teachers has done a really great job where you online can take these little boxes and fill them in like you see in number one. I'm going to do it a little different way because when it comes to GCF, you're looking for the greatest common factor. You're not necessarily doing factor trees, which we'll see later. So what we're doing here is what I would suggest you do is for 30, I want you to list out the all the factors of 30. So you can have 1 and 30, you can have 2 and 15, you can have 3 and 10, 4 does not have a whole number, 4 would be a fraction, and then 5 and 6. So those are all of the factors of 30. And then for 22, we're going to do the same thing. We have 1 and 22, we have 2 and 11, and that is it, right? So now we're looking, what is the greatest number out of these that is common, that is present in both of them? So they both have a 1, right? But that's never going to be your greatest common factor. They both have a 2, so that is true. This one has an 11 and a 22, and that 11 and 22 is not present over here. So that means our GCF for this is going to be 2. Okay, so I'm going to do a lot more of these just to practice, but I'll kind of show you, and hopefully you'll catch on. So 1 and 35. 35 is odd, so there's not going to be 2. 3 would not work. 4 would not work. 5 would be 7. And that is it there. Now, how you can do this is you can go to your calculator, and I'll show you on a calculator that I have downloaded. And I've given you this in the helpful info page. But if you go to y equals, and let me clear out what I have for these two, what you can do is you can type in whatever number, so 84 is what we're looking for, divided by x, and then go to your table. And if you see, we have 1 and 84, 2 and 42, 3 and 28, 4 and 21. You know, you can just continue to have those numbers right there, and you'll keep going until the numbers change. So you see right here, we have 8 and 10.5. Then we have, oh, hang on. Let me go back. We have 8 and 10.5. Then we have 9 and 9.33. So the left numbers, the x column is still smaller. And then it changes. It goes from 10 to 8.4. So now that when the x column gets bigger than the other column, that's when you stop. So there's nothing else you can do there. So we're going to copy down that list of numbers. It'll be 1 in 84, 2 in 42, 3 in 28. Let me do it in my calculator so I can see it. 84 divided by x. 3 and 28, 4 and 21. Oh, I knew that. I didn't need that. 5 is a decimal, 6 and 14, 7 and 12, and that looks like that's the last one. So again, now we're looking for the greatest common factor between these, and you can see it is 7. 7 is the biggest number between both of these. Okay, so that GCF will be 7. For number 2, 120, you can do the same thing. We have 1 and 120. We'll go back to my y equals. 120 divided by x. So here's the thing. When you see 120 and 100, a lot of people, the very first thing they see is they go, oh, okay, well, that's got to be 10 because they're both divisible by 10. But that might not be the biggest or the greatest common factor. That is a common factor, but it might not be the greatest one. So what you can do is you can actually put both of them into the calculator at once, and we'll see 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20. I'm going to keep going. 7 does not work. 8 and 15, 10 and 12. And then if I keep going any further than that, it will not work, and those numbers start to flip. So then we'll do the same thing with 100. 1 and 100, 2 and 50, 3 doesn't work, 4 and 25, 5 and 20, 6, 7, 8, and 9 do not work, and then 10 is 10. So now we're looking for the greatest common factor. So you might say, well, hey, yeah, there's 10, so we're good. But there's a bigger one, right? If you notice, they both have 20 as well. So let's check the numbers that are bigger than 20. Does the left one have a 25? No. Does the left one have a 50? No. Does the left one have a 100? No. So your GCF here is 20. Now, most likely, I'm not going to give you some crazy difficult numbers. You might see something like number 7, though. You would probably most likely see something like number 7. So what I want you to do here is just understand that there are multiple different methods to do this. And if you find another one, that is perfectly fine. Like, I am completely okay if you find another method to do this and you prefer it over this. Because soon enough, you'll be able to just look at the difference between the two and see what they can both be divisible by. So 1 and 42, we'll do 42 divided by x in our calculator and 63 divided by x in our calculator. Go to the table and start writing down all the whole number pairs. So 3 and 14 would be the next one. 6 and 7 would be our last one. So for 1 and 63, 2 doesn't work. 3 and 21. And then 4, 5, 6, 7, and 9. And that should be our last one as well. So now we just look and see what the greatest common factor is. And that would be 7. All right, so the way we're going to apply this is looking at problems like this. This is what you will see. You will rarely see me give you any problems like what we had before. So for this one, we're looking for a GCF of 24 and 36. So we're looking at the numbers first. 24 and 36 are both divisible by 12. So I'm going to put 12 first. And then what you need to look at is the variables and whether they are present in both terms. So our first variable is x. Yes, x is present in both terms. And then we're going to take the smallest one. So that's going to be x squared. So I'm kind of taking this away from these. So in other words, I can't take away x to the 9th away from x to the 2nd because it only has 2 x's, right? If I have 9 slices of pizza, or if I have two slices of pizza, you can't take 9 away from me, right? So you can only take away what I have. So that's what we're doing here. There's a y present in both terms, so we're going to take out a y as well, and that's going to be to the first power because that's the smallest. So 12x squared y is our GCF there. We'll do the same thing for the next one. 48 and 12, they're both divisible by 12. And here we have 12, and we do have an x in both of them, and squared is the least one. And then we do have a y, and y to the first is the least. Now you see we have a z here. That z is just going to stay there because we don't have a z in this term. So we can't take it away. It's not a greatest common factor because it is not common or present in both terms. So x squared y is your answer there too. And I'll let you do the last one. For number 2, 18, a to the 5th, b to the 4th. Now 18 and 54, we can kind of do this off to the side if we'd like. That'll be 1 and 18, 2 and 9, 3 and 6. 1 and 54, 2 and 27, 54 and 3. I don't think so. Nope, 18. Yeah, it does. Oh, well, there we go. We got it. So 18 is the highest number up here. So we can just go ahead and stop and know that it's going to be 18. So 18. And then a. We do have an a in both terms. And the lowest one is a to the first. So we're just going to leave it as a. We do not have a b in both terms. So I can't take out a b. We also don't have a c. We also don't have a c in both terms. So we can't take out a c. So here, our example, our greatest common factor is 18a, and that is it. There's nothing else you can take away from that. All right, so you get into more difficult ones, but this is perfectly fine. All it is just more variables. Still take it step by step. So for 24, we would have 1 and 24, 2 and 12, 3 and 8, 4 and 6. For 27, we'd have 1 and 27, 3 and 9, and that's it, right? Yeah, so 3 is our greatest one here. So 3, when you look at the m's they are present in both of them, and m to the second is our smallest. We do have a y in both of them, and y to the third is our smallest. And we do have a z in both of them, and z to the fifth is our smallest. So really not nearly as bad as it seems, right? We'll do the same thing for number 4. Now, 30 and 7, okay? You will never have a GCF of 1. 1 will never be your answer because it really doesn't change anything, right? So if we have 30 and 7, 30 would be 1 and 30, 2 and 15, 3 and 10, 5 and 6. 7 is just 1 and 7. So the only GCF we have here is 1, which we never put as a GCF. So that means we're not going to have a number here. We're just going to have the variables. Okay, so the only common thing we have here, we both have an r. So we're going to take out the smallest, r to the first power. This second one does not have an s, so we can't do it. And this first one does not have a q, so we can't do it. So our GCF is just r. That's it. Nothing else. For number 5, 150. Obviously, 50 can go into both of those, right? That one you don't even need to write it out. X squared and x is present in both of them, so we take the smallest. Y, it's present in both of them, so we still take the smallest. And z, it's present in both of them, so we take the smallest. So hopefully that will help you out with GCF. We will do another review tomorrow on this exact same sort of stuff. If you got any questions, feel free to reach out to me through email.